Section 2 begins with Unit 5 and the addition of common fractions. Now, fractions are simply the division of a singular unit into equal parts. If I was to take this circle that I've drawn here, divide it in half, each one of those would be 1/2. The 1 being the whole, the 2 being the number of divisions I've divided into. If I divide it again, that 1 is divided by 4, or divided into 4 separate pieces. If we were to divide that yet again, that would be divided into 8 separate sections. There's the 1 and the 8. Now, if we were to choose just, say, 2 of these sections, that would be 2/8, and 2/8 is the same as 1/4. If you add 1/4 plus 1/4, that equals 2/4. Now, it's common to reduce your fractions to the least common denominator. This top number is the numerator. That tells you how many sections of that total you're going to use. The bottom is the denominator. And it tells you how many parts that whole is cut into. If you have 2/4, you can reduce that by 2, then that becomes 1/2. Okay? We can do another one really quick. Let's slide this down. What if you had 1/4 plus 3/4? Now, when you're adding fractions, your denominator has to be the same. So you just add the numerator. So 3 plus 1 is 4. The denominator stays the same. So 4/4 is the same as saying 4 parts of a unit carved into 4 parts. So that becomes 1. And what I've just explained to you covers the first 2 basic principles of fractions. Fractions are used to divide units into equal parts, and it's a common practice to reduce those fractions that you come up with into their lowest terms by dividing both the numerator and the denominator by the same number. So let's just say you had a couple of fractions to add, but they didn't have the same denominator. Let's say you had, let's look at our review problems on page 18. Let's say you had 1/2 plus 3/4. Well, you can't change the 1/2 because it's least value. But you could change that. Say you change that 1/2 into 2/4. Okay? Now the denominators are the same, and you add the numerators, and that becomes 5/4. But as we've seen up here, 4/4 is 1, so that's the same as saying 1, and 4/4 from 5/4 leaves 1/4 left, so 1 and 1/4 is the answer to your C question on your review problems. But that one was very simple. All you had to do was multiply by 2. And realistically, as a machinist, that's the numbers you're going to see. You're going to see everything is going to be divided into these simple ones. Either going to be 1/2, or it's going to be 1/4, or it'll be in quarters or fourths. It'll be in eighths. It'll be in sixteenths. It'll be in 32nds or 64ths. Any variation of your numerator above your denominator, this is what you're going to see as a machinist, because that's what we typically use, are those. But let's just say, for theory's sake, that you wanted to add, what if you had 1/2 plus 2/3? Well, how would you make these two denominators the same? The simplest way is on this side. If you multiplied this side by the same number for your numerator and denominator, let's just take the denominator on this side, the 3, and on this side you would take the denominator on this side, and as we saw before, 3 over 3 is the same as 1, 2 over the 2 is the same as 1. So anything times 1 just remains the same. So if we took 3 times 1, that's 3. 3 times 2, that's 6. Plus 2 times 2 is 4. 2 times 3 is again 6. Now our denominators are the same, so we can just add our numerators. 4 plus 3 is 7, and 7 over 6. The numerator is larger than the denominator, and you'll see this from time to time. So we know that 6/6, 6 over 6 is 1. So 6 from 7 leaves 1, so 1 and 1/6 is your answer there. Let's try one more. Let's try 2/3 plus 3/4. Once again, it's not real easy to come up with a number that both of these will match, unless we take this 4 and we multiply the first number by 4 over 4 and the second number by 3 over 3. That becomes 4 times 2 is 8. 3 times 4 is 12. Plus 3 times 3 is 9. 3 times 4 is 12. Now we have the same denominator. All we have to do is add the numerators. 8 plus 9 is 17. And the denominators say the same. So 17 over 12. Now it's greater than 1, and 12 over 12 is 1. So if you subtract 12 from 17, we get 5/12. And that's the smallest number that we can reduce that. So for your review problem on E, there's your answer. And I hope this helps, and we'll see you next time.